This video discusses Boyle's law. Boyle's law stated that at constant temperature, pressure is inversely proportional to volume, meaning as pressure increases, volume decreases, and vice versa. So as volume decreases, pressure increases. So this is the start of our working equation. So by removing the proportionality symbol, we will introduce K. So, P equals K times 1 over V. K is constant in any situation. So, meaning whether we have initial pressure volume and final pressure volume, it's always constant. So, the product, because if we will cross multiply, P times V equals K. So, meaning the product of pressure and volume is constant all throughout the conditions of the system. So, whether we have an initial pressure and initial volume, this is equals to K. And we have P2, which is the final pressure and final volume. This is equal to K. Since K is constant, we have a working equation which is P1V1 equals P2V2. Now, let's solve our first problem. So, a gas at 820 millimeters mercury has a volume of 8.0 liter. What is the new volume of this gas at standard pressure? So, it will be useful if you will use your GRESA. So, given and required. So, for our given, we have pressure 1, which is 820 millimeters mercury, and has a volume of 8 liters. So, our initial volume is 8.0 liters. Now, for our second sentence, what is the new volume of this gas? So, new volume of this gas at standard pressure. So, what is the standard pressure? We know that standard pressure is 1 atm. And 1 atm is also equivalent to 760 millimeters mercury. Alright? So, since we are solving Boyle's law, our working equation is P1V1 equals P2V2. Alright? So, let's now start solving. So, this is just substitution. So, for our solution, it's P1V1 equals P2V2. P1 is 820 millimeters mercury times V1, which is 8.0 liters, equals P2, which is 760 mmHg. You notice that I use 760 millimeters mercury, not 1 atm, because we want our units to be consistent. So, we have one equation, one unknown. You can just solve for V2 as your final answer. So, V2 is simply 820 times 8 divided by 760. So, our answer is 8.631578 ... But we have to express in proper significant figures. So, we have two significant figures. So, our final answer is 8.6 liters.